In order to simplify this expression, we're going to take advantage of the fact that the two fractions we're trying to add are conjugates to do a little manipulation and end up with the same denominator so we can add them together. We're going to multiply the first fraction by 1 minus cosine theta over 1 minus cosine theta. The conjugate of the denominator over itself, meaning we're multiplying by 1, not changing the value. But now, if we multiply the second fraction by 1 plus cosine theta over 1 plus cosine theta, its denominator's conjugate over itself, again we're multiplying by 1, not changing the value, but we'll end up with a common denominator. So we'll have 1 minus cosine theta in the numerator, and 1 minus cosine theta plus cosine theta minus cosine theta squared in the denominator. In our second fraction, in a very similar pattern, we'll have 1 plus cosine theta in the numerator, and in the denominator we'll have 1 plus cosine theta minus cosine theta minus cosine theta squared. You can see we have positive and negative versions of cosine in both denominators, so those will cancel, and what we'll be left with is 1 minus cosine theta in the numerator and 1 minus cosine theta squared in the denominator, plus 1 plus cosine theta in the numerator and 1 minus cosine theta squared in the denominator. Now we have a common denominator. We can add the two fractions together by adding the numerators. We'll have 1 minus cosine theta plus 1 plus cosine theta all over 1 minus cosine squared theta. And that's going to equal 2 over 1 minus cosine squared theta, which we can simplify using a Pythagorean identity to 2 over sine squared theta. And we can rewrite that as 2 times 1 over sine squared theta, and then use a reciprocal identity to complete our simplification and get our final answer, which is 2 times cosecant squared theta.